In this video, I'd like to continue talking about the formula for the area of a trapezoid. And in the last video, we looked at a way to derive the formula by splitting up the trapezoid into two different triangles and a rectangle, and essentially just adding the area of each of these shapes together and then rearranging the formula. So in this video, I just want to look at a slightly different way to approach finding the formula. And remember that a trapezoid is a quadrilateral where it has one set of parallel sides. And the formula, we can just say the area of the trapezoid is equal to the height of the trapezoid, which we can just draw a perpendicular line between the bases, multiplied by the average of the bases. And we can call those B1 and B2. And we're going to add those together and divide by 2 since we're finding their average. But we can call this B1 and this can be B2. And of course, this vertical line, this is the height, the difference essentially between the two bases. So instead of breaking this trapezoid up into the two triangles and the rectangle in the middle, we're going to split this into two different triangles and then just add their areas together. So our first triangle, we want to use base 2 as its base and h as its height. So we can draw the triangle across like that. And actually, let me use the line tool. Or we could split it the other way if we want. We can go from this corner to here. It doesn't matter. In either case, the bottom triangle would have its base as B2 and its height as h. And likewise, the top triangle will use B1 as its base and h as its height. So it doesn't matter which way you split it. The main idea is you get two different triangles that we can find the area of. So if we call this triangle A and this triangle B, then the area is just going to be the sum of these. So let me just make a little bit of room and we can start computing that. So the area of our trapezoid will just be the area of triangle A plus the area of triangle B. And remember, the formula for the area of a triangle is just half the base of the triangle multiplied by the height of the triangle. So let's start computing this. And for triangle A, it has a base of B1 and its height is h. Remember that the base and the height need to be perpendicular. So we'll take half of base 1 and multiply that by the height h. And now we need to find the area of triangle B. So that has a base of B2 and a height of h. So the area for that will be half of base 2 multiplied by h. And from here, we can factor out h since they both have h in it, each of these terms. So when we factor it out, we're essentially dividing each of these terms by h. So we get half of b1, or I'll just write b1 over 2, plus half of b2, or b2 over 2. And from here, notice we have two fractions and they have a common denominator, so we can just add the numerators. So adding the numerators, we would just have b1 plus b2. And that is the formula we derived in the last video. It's the exact same formula, but it might be a little bit easier to derive it this way, since a lot of times breaking up these trapezoids into two different triangles is the simplest way to find their area if you don't know what the formula is. So remember that with this formula, we are taking the height and multiplying it by the average of the two bases. So if we look at an example problem, let me scroll down, let me create a quick triangle or trapezoid here. And with this trapezoid, the top base, we can call this B1, has a length of 8. Let's just say it's 8 meters. The height is 5 meters, and base 2 is 14 meters. So if we wanted, we could treat this as a composite shape and split this up into two triangles and then find the area of each and add them together. Or we could use the formula. So let's use the formula just to practice that. And remember, the area is just the height multiplied by the average of the two bases. So the height is 5. So we have 5 meters multiplied by the average of these two. So we're finding the middle number. And you might recognize that that would be 11. Or we could just add them together and divide by 2, since there are two numbers that we're averaging. So when you add these together, 8 plus 14, that's 22. And 22 divided by 2, that is 11. So you get 5 meters multiplied by 11 meters, which is 55 square meters. Since we're multiplying meter by meter, we get meters squared or square meters. And you should get a square unit anytime you're dealing with area of some flat space. So a way to interpret this formula is that when we found the average of the bases, basically we transform this shape into a rectangle. Since when you're finding the average of the bases, you're finding the line that's parallel to the bases that goes right through the middle of the trapezoid. And it's not perfectly drawn, but you can get a rough idea. And the length of this, we calculated, was 11 meters. And to transform this to a rectangle, we want to draw perpendicular lines at the intersection point between this new line and the two sides that are not parallel. So let's drop some perpendicular lines, and we're able to form a new triangle here that wasn't in the original picture. And we'll do the same on this side, where we can again draw a new triangle. And basically, this new missing triangle on each side is the same as the one on the bottom. So we would take this triangle and it could rotate up and fill in here. And same for this triangle. We could rotate it up and fill it in here. And again, this is not drawn perfectly, but if this was drawn by, let's say, a computer, then these triangles would be exactly equal, and same with these two. But the main idea is that now we have a rectangle where the height of the rectangle, or we can say the width of the rectangle, is 5 meters, and its length is 11 meters. So to find the area of that rectangle, we just multiply it width times length, 5 times 11, and we do get 55 square meters. So a way to interpret this formula is that we are just transforming the trapezoid into a rectangle and then finding the area of that rectangle.